Welcome to the H2O AI Hybrid Cloud, an end-to-end platform that enables organizations to rapidly make world-class AI models and applications for virtually any use case. The platform empowers everyone in an organization to innovate and use AI to solve their most pressing problems, such as making better forecasts, streamlining operations, reducing risk, and personalizing customer experiences. We'll start by looking at the H2O App Store, a front end for users to browse and use AI apps to solve their specific use cases. The AI Hybrid Cloud runs internal to a company, allowing each organization to have their own app store with the apps most important to them. In addition to data science best practice apps curated by the H2O Kaggle Grandmaster team, the industry vertical apps built by the makers at H2O, your engineers and data scientists can build your own applications to make your company an AI company. These applications are powered by state-of-the-art automated machine learning from H2O and Driverless AI. As a technical note, the instances which run the AutoML capabilities are hosted within the hybrid cloud backend and managed automatically by H2O Steam. As an example, today we will look at a customer churn application. This is an easy-to-use front-end for real-time predictions of a machine learning model, which tells us when someone calls our call center whether or not they're likely to churn and why. The goal of this application is to empower our call center representatives with AI so they can make more informed decisions when talking to their customers. The predictive model driving this application will be built by our data science team in Driverless AI. Then, they'll productionalize this with model ops so that it can be consumed by the application. In today's video, we'll walk through this end-to-end process. Welcome to Driverless AI. Here is H2O's award-winning AutoML software, which supports tabular, time series, text, image, and video data all in one platform. We can see the datasets I've previously uploaded and the option to bring in new data. I can easily connect to where data lives at my organization with over 12 connectors to standard stores, including a JDBC connection to most any SQL warehouse. Today, we'll be looking at a historic churn dataset. We have information about each of our customers, like how much they're paying for service and demographic details. We also know, historically, who's left our company. Building models in Driverless AI is easy for the data scientist. We only have to click the Predict button and then tell Driverless which column from our data we wish to predict, in this case, churn. Now, many default settings have been selected for us based on our data and use case. Our advanced data scientists may want to use the expert settings to have full control over exactly what will happen during an AutoML experiment. After we launch the experiment, our automated machine learning process will build many models that compete against each other with the goal of finding the best model for predicting, at this company, which customers will churn. This process includes trying different data science algorithms, doing feature engineering, the process of massaging the original data so that it will work with machine learning algorithms, and then also turning each of these models. At the end, our data scientists will get the single best model, or ensemble of models, for this use case. I'm going to jump now to a completed experiment. Here, we can see in about 30 minutes, we tried over 400 different models and 450 new features. This saves our data scientists a lot of time from testing different algorithms and input features, freeing up their time for tasks that need a human touch, such as explaining this model to the business team. Every Driverless AI model comes with automatic model documentation, explaining exactly how the model works and what happened in this experiment. The H2O AI Hybrid Cloud also has an automatic model documentation app, allowing your users to quickly document DAI and also H2O models. Before discussing these results with the business team, our data scientists will first want to use the diagnostics to understand how well the model is performing, and then the machine learning interpretability to understand how the model actually makes decisions. This allows us to better trust the results. This module has over 15 different data science-focused ways of understanding how a model makes decisions. Shapley values show us how much each feature contributed to overall predictions. This is particularly helpful at the local level, where you can see positive and negative contributions. These reason codes can be used by our business application so that someone calls the call center, our rep knows things like their payment is double as negative as their international plan, which they're happy with. Partial dependency plots allows us to see how predictions would change if one specific feature changed. Here we can see the average prediction goes from unlikely to churn to likely to churn as the payment amount increases. We've walked through how a data scientist would build a model and how we'd understand how the model is working. We can now go to the Projects tab to organize our work for a specific use case. This project and all the experiments in it will automatically be available to our operations team in ML Ops. I have previously deployed 2 models, one to my dev environment and one to production. These models are running live as REST endpoints, and our business application can send requests to them and get back predictions. ML Ops includes functionality your team may be doing manually today, such as monitoring how often a model is used and what the data being sent to the model looks like. This can allow for automatic retraining when the model gets stale. We've built a model, we have it running in production, and now we're ready for this model to drive predictions in our customer churn application. This sample application shows how we can wrap up the work done by our data scientists into business-friendly applications to solve real problems. An analyst can begin by exploring our customers who churned last month. We can see information about customers, look at if they churned or not. We can see that California and Texas have almost 25% churn, telling us this could be a good place to focus for our coverage and support. We can also see the distribution of bill amount for customers that did and did not churn, showing us the unsurprising fact that customers with a higher than average bill are likely to leave for a competitor. We'll now go to the real-time churn dashboard. At the top, we have a list of customers as they're calling in. We can see their likelihood to churn and their current monthly bill. Below, we have our churn by state and churn by bill dashboards. This is all updating in real time with today's results. Everything we see on this dashboard is predictions coming from the model that we just looked at in ML Ops. As customers call in, this application sends their data to the model and the model sends back predictions. To build this application, our data science or app development team only used Python. This is done with the H2O Wave software development kit. This is an open source Python library and web server that allows for building applications like the one we walked through today. The Wave SDK allows for easily building interactive UI components, like this side panel with buttons, without having to know any front-end skills like JavaScript or CSS, and without having to think about typical client-server interactions. Because it's all Python, it's easy to integrate with your favorite Python libraries and build apps powered by AI. Today, we've talked about the capabilities of the H2O AI hybrid cloud through a single use case. We talked about how AutoML instances are managed with Steam. We walked through building a model using Driverless AI. But there are other data science-focused apps, such as Automatic Insights and Responsible ML. We looked at how Model Ops can host productionalized models for us and how these models can be used within Wave applications, both apps from the makers at H2O, but also apps built internal to your organization. H2O AI Hybrid Cloud is deployed on Kubernetes, enabling customers to operate on any cloud or on-premise infrastructure. When you're ready to start innovating, just visit our Getting Started page. Thanks for your time today and joining us to talk about the H2O AI Hybrid Cloud.